everybody. My name's Gareth Dyke, and I'm the Author Relations Director at Bentham Science Publishers. We are absolutely delighted to be participating in this Malaysian Technology Symposium Sustainable Development Goals presentation and workshop and webinar series. Today, it's absolutely fantastic. What we've done for this event is we've sponsored a number of awards that will be presented later on during the proceedings, and we've also prepared this short presentation about some of our Bentham Science research. You can learn more about Bentham Science by having a look at the BenthamScience.com website or EurekaSelect.com. As you can see here on the screen, you are able on EurekaSelect.com to learn about all of the journals, more than 160, and all of the ebooks, more than 1,300 that Bentham Science publishes. Many of those aligned with the UN SDGs. Here you can see a link that provides you with access to our collection of books, our collection of ebooks that are aligned with the UN Sustainable Development Goals. You can go to this link /SDG-ebook. We'll provide you with all of these links and see which of the Bentham Science content aligns with the different 17 UN Sustainable Development Goals. So let's have a look quickly at Zero Hunger. Click through there. Lots of content organized as a collection, Bentham Science ebooks that relate directly to that sustainable development goal. If I have a look at quality education, if I click through on that one, you can see again, lots of content around the UN Sustainable Development Goals around, quality education. And there at the top, a crisis like no other, understanding and defeating global warming, one of our speakers today. We'll come back to that in just a moment. We also have another page that you can have a look at on EurekaSelect.com /SDG-journals, which again brings you through to all of our journal content relating to the UN Sustainable Development Goals. So here on SDG number 2, Zero Hunger, you can see the journals that Bentham Science publishes that relate directly to that particular SDG. Letters in Functional Foods, Current Functional Foods, Current Nutrition and Food Science, and so on. Don't forget that Bentham Science is the only international publisher that provides you with patent reports. Very unique, very important offering that we do have. And there you can see recent patents on food, nutrition, and agriculture. So these are key. I'm going to start off by introducing 3 of our presentations for the beginning of our session today. First off, we'll have a short presentation by Dr. Kenneth Bloom, who is a full research professor at the Western University Health Sciences in Pomona, California. We're then going to have a presentation by Dr. Thomas Lehr from the Institute of Human Genetics at the University in Jena in Germany. And then finally, we're going to be having a third presentation from Dr. Yik Ling, who is an assistant professor at UCSI University in Malaysia. Dr. Yik Ling Chu will be presenting on her work, mangosteen peel extract, your sustainable ingredients for lustrous locks and dandruff-free hair. And then finally, we're going to come with a 4th presentation talking about global warming. And that one I'll introduce separately in a moment. So sit back, relax, and enjoy our Bentham Science presentations, research relating to the UN Sustainable Development Goals. And thank you so much for listening. My name's Gareth, and this is Bentham Science. Don't forget to have a look at EurekaSelect.com.
I'm Kenneth Blum, a full professor at Western University Health Sciences in California. So we have a major crisis, the opioid crisis, but it's really extended to all drugs of abuse, psychostimulants, alcohol, and other problems. So, but we'll kind of gear towards solving the opioid crisis if possible. I can say one thing, and that is the way that we are doing it in America. We are giving opioids, very powerful opioids, to opiate dependent individuals. We're ending up with 111,000 premature deaths in 2022. So we have to start thinking out of the box. What I'm going to present to you is the thinking out of the box as a new way and a new approach to deal with the opioid crisis and other drugs. So if you look at this chart, it's called a problem analysis tree. Basically, I am going to discuss the genetics and potentially some of the epigenetics and the idea of developing a genetic test that could actually identify very early on an individual's pre-addiction. And the idea of pre-addiction is something that has been around since the 70s.
Hello, thank you for giving me the chance to talk here about a topic which I was really interested in and dealing with during the last months, which is about challenges and ethical issues of non-invasive prenatal testing. I'm happy to present this data here on the Malaysian Technological Expo. Non-invasive prenatal testing, the NIP test, has been introduced in the last 10-15 years in Europe and worldwide to accompany the invasive prenatal test possibilities which are showing here. So if someone expects a baby, you can do 3 types of invasive diagnostic testing. This is chorion villi biopsy, amniocentesis, and chordocentesis. And the risk for intervention nowadays in Europe is 1 in 500. That means 1 baby may die because of the intervention, and the other ones will go on normally. One problem in connection with this risk figures is that formerly the risk figures were much higher. In the 1980s, they were around 1 to down to 0.3%, but nowadays they are much lower, as I said. But when you check in the internet, you will see data. So sorry, the following is in German. That here it was from last September that. Here the risk figures are still given as the old figures, as 2 to 4% or 1 to 2% for an invasive diagnostic testing. And this is one of the reasons why people recommend the NIP test as a risk-free possibility to. So this, what I showed you before, is just one example of many problems which are to be mentioned and to considered in connection with the NIPT. And I want to go through with you here the problems which I came about. So the first challenge is the biological challenge. The DNA which is tested, which is called in the literature as cell-free fetal DNA, CFF DNA, is indeed derived not from the fetus. There's not one single molecule derived from the fetus. It's all derived from cells which are dying from the trophoblast, so that means from the placenta. And this is a problem because there may be a discordancy of placenta karyotype and fetus karyotype. The next problem is that the NIP test is based on NGS, next generation sequencing or whole genome sequencing, and that people who offer the test and also the patients need to understand possibly differences of the different tests which are behind the NIP test. And this is because without going into details here, just it needs to be known that there are more than one possibility to do the NIP test technical wise, and that according to the technique you use, you may detect triploidy, for example, or you may not detect a triploidy. And these things need to be understood by the medical doctors offering the test, but also by the patients taking the test. Another problem is that the proportion of so-called cfDNA is rather small compared to the maternal free DNA. So you see here the yellow one would be the maternal DNA, the whitish one would be the fetal DNA or the placenta DNA, and this region is called the fetal fraction. It may now be that this fetal fraction is so small that you can have also no-call results, and this is also something which needs to be explained to the people taking the test. Because this means that it can be, and this affects 5 to 10% of the tested persons, that a NIP test in the first attempt does not work, and you need to wait 3 to 10 days after the blood collection that you learn that the NIP test did not work, and that means then it has to be repeated, and there's no data available in how many of these tests where it's repeated, then people get a result. One consequence of this small amounts of DNA we are dealing with in the NIP test is that people have difficulties to present the data they have, and so they had to choose ways for presentation of the data which are unusual and where neither the medical doctors nor the patients are used to. One is that the proportion and the differences of the DNA, and if there is a gain of copy numbers or loss of copy numbers, is given as a set score. And the second thing is that the reliability of the test is given as PPV, that means positive predictive value. I guess normally people don't know what a PPV is. And at the moment there is something like a chaos in the literature how a PPV is calculated. So we can find different ways to do that. And I will show you on the next slide why they choose the PPV rather than the percentage of the reliability of the test. So before I come to what I just announced is that there's another technical problem. In the literature, there is the focus always on the pregnant woman tested negative in a NIP test. But those people who get a negative test get a relief that their baby seems to be okay. Those who get a positive test are frightened. And here you see the data, which was found on based on a literature review of 750,000 cases. Of the about 9,000 positive NIPT cases, there were 2,000 false positive, which means 22%, and 75 false negative, which is about 1%. And why people give this kind of data then as some kind of PPV and not as the percentage of false positive NIPT in the NIPT positive cases? This is shown here. If you check trisomy 21, the PPV is something like 95, also often given falsely as 95%. Indeed, that means that about 10% of the cases had a false positive NIPT result, but a PPV of 95 sounds much better than saying that only 90% of the cases had a correct result. And this goes on further. So if you look at trisomy 18 and 13, the reliability is much less. So you have a PPV of 69 in trisomy 13, which means you have 44% of false positives. And if you go further down, this goes even down to practically no reliability at all for microdeletion syndromes. And also, when you look in the literature why you have these different kinds of sensitivities and specificities for different operations, the reasons are not explored, and there's no papers about that. In this challenge, why NIP test is hard to interpret is coming back to the fact what I mentioned in the beginning, that there is a difference if you test the fetus or the placenta. And the problem is that you have here placental mosaics and so-called confined placental mosaicism. That means you may have a trisomy 21, for example, in the placenta, which you would detect by the NIP test, but you would have a normal fetus with no trisomy 21 because the trisomy 21 was avoided. And this is also the reason why all NIPT companies indicate to confirm aberrant NIPT test by invasive diagnostics. So this is exactly what should have been avoided by the NIP test, to do an invasive diagnostic testing then. Besides that, you can have this confined placental mosaicism. There can also be the other biological problem that you can have a change of the chromosomal constitution in the pregnant woman herself, because you always compare the maternal free DNA and the free fetal DNA. And if the woman has has 3 X chromosomes instead of 2, or 1 X chromosome instead of 2, then there may be a false positive result for a gonosomal aberration in the fetus. And if what is much less frequent, where a woman has a tumor which is undetected, you can also get a false positive NIPT test result. Besides, there can be also a vanishing twin, which can also influence the NIPT results. The main problem, which is a medical one and listed here, is that people, if they get a negative or normal NIPT result, they consider in most cases the child will be healthy, or if it's positive, the child will be definitely sick. I showed you in the slides before that this assumption is wrong. Already further cases with aberrant NIPT results or maybe wrong, and here I show you that if you put together all the possibilities which may lead to a deceased child somehow, only less than 5% of the cases can be accessed by the NIPT test, which is shown here in light green labeling. So beside the challenges I mentioned, there are also often mentioned points which are ethical problems, which are listed here, which are also to be considered. But from my point of view, the real ethical issue is how a NIPT test could be now financed by many societies worldwide, and how such a problematic test could be hyped alike like it was by now. So overall, the point is for the NIPT test to decide for the people who offer it, who provide it, if we should do such a problematic test or not. Thank you for listening.
A very good afternoon to all the MTE audiences. My name is Yek Ling, and I'm from the Faculty of Pharmaceutical Sciences, UCSI University, Malaysia. I would like to thank BenthamScience for this opportunity for me to share my product innovation aligned with SDG goal to all the audiences in MTE. And my product is the anti-dandruff hair shampoo using the mangosteen peel extracts. For your information, mangosteen is also called as Garcinia mangostana. It is rich in anthocyanin, xanthones, phenolic acid, flavonoids, and flavonols. Literature has reported that the peel consists of 69% of alpha-mangosteen, and there are various biological activities have been reported in the mangosteen peel, such as antifungal activity, where it can fight against the dandruff-causing microorganism, antioxidant activity, where it can scavenge free radicals in the environment, anti-inflammatory activity, where it can inhibit inflammatory factors and treat hair folliculitis and scalp rashes, hair rejuvenation properties. It can stimulate the hair dermopapilar cell, and it can boost the hair growth, and also hair tanning properties, where it can promote melanin pigment synthesis. Our team have invented a hair shampoo using only natural and natural derived ingredient. For instance, we have used several natural ingredients as a surfactant, thickener, fragrance, conditioner, special additives, sequestrin, and preservatives. We have named the shampoo, which is produced using the mangosteen peel extracts, with the name of Stinfix. Stinfix has been formulated exclusively with natural and plant-based ingredients. These ingredients are able to cleanse the hair scalp gently and give hydrated, silky feel to the hair after the wash. And our product has unique blends of ingredients that can strengthen, calm, hydrate, and protect the hair. And our product can also reduce the frizziness of the hair. Our product has been tested in the lab, and it is scientifically proven. Our product is proven to be able to inhibit the dandruff-causing fungal, and bacteria that can cause inflammation of the hair follicles. And our product also has an excellent antioxidant activity that can scavenge free radicals that could damage the hair scalp and weaken the hair strength. Our team has observed the hair scalp using the hair scalp microscopic examination, and it was found that our shampoo could effectively clean the hair scalp, remove the sebum from the scalp with only one wash. Actually, a clean hair scalp promote a healthy hair growth. So when the hair follicles are clogged with dirt and excess oil, it can lead to hair loss, breakage, and a dull appearance. So a clean hair and scalp will allow for better circulation and oxygenation, which can improve the hair quality. So from these two pictures, it shows that our product Skin Fix can actually unclog the oily scalps, and it gives a clean, healthy hair scalp with only one wash. Our product is different to the commercial product in the market. The reason is because we use only the natural and natural derived ingredient, and our product is free of paraben, phosphate, sulfate, synthetic colorant, silicone, synthetic fragrance, and it is also cruelty-free. Our product is also pH balanced. It is suitable for all hair types, suitable for daily use, hypoallergenic formula, it's lab tested, it is moisturizing, and also the formula is an eco-friendly formula. Product is aligned to 4 United Nations Sustainable Development Goals, such as SDG 3, Good Health and Well-being, SDG 12, Responsible Consumption and Production, SDG 14, Life Below Water, and SDG 15, Life on Land. Our product innovation had also won the Gold Award in the Malaysia Technology Expo this year. Our research has several publications available, and for further reading, you may access and read our research publication, which is listed here. For this product innovation, we would like to thank Faculty of Pharmaceutical Sciences and UCSI University for constant support in terms of facilities, and the Center of Excellence for Research, Value Innovation, and Entrepreneurship Survey for the research funding support. Last but not least, I would like to express my gratitude to my research student, Ms. Jewel and Mr. Henry, for their hard work and dedication in the research project. That's all my sharing. Thank you for your attention.
Last but not least, I'd like to introduce a Bentham Science book author. Robert DeSaro is the author of A Crisis Like No Other, Understanding and Defeating Global Warming. Over to you, Robert.
Hello, this is Bob DeSaro, and I'd like to discuss global warming, and specifically, as the title states, is there anything we can do, or is it game over? And it's quite a bit we can do, and it's quite a bit we are doing, but we need to accelerate our efforts. About who I am, I've been studying global warming for over 30 years, and I've been studying various aspects of it, the psychology of global warming denial, for instance, how we can overcome that denial, how we could find facts amidst the sea of fake news, what global warming is from a science perspective, what we can do about it, and what sort of solutions are available to us. I have currently active research projects in areas related certainly to global warming, processing spent nuclear fuel, for instance, a project where I'm creating hydrogen from biofuels, recycling metals, energy conservation, and more. So I've taken the years of my experience and knowledge and put it in a book, A Crisis Like No Other, Understanding and Defeating Global Warming, published by Bentham. before I discuss the solutions that we have, I'd like to first set the table by stating a couple of facts, kind of important for setting up what I'm going to be talking about as to what we could be doing. So first item is that the Intergovernmental Panel on Climate Change has declared that we must stop the net emissions of all global warming gases by 2050. The reason for that is that CO2 molecules, a greenhouse gas, when they're emitted, they stay in the air for many, many, many generations. It's sort of like a bucket of water. You know, the more we keep filling the water in, it doesn't go anywhere until it spills over. Well, it's the same thing here. We keep putting CO2 in the air and it stays there. And so we really need to cease all greenhouse gases by then if we want to keep our atmospheric temperature rise to 1.5 degrees centigrade. We go beyond that, then temperature goes up even further and it gets worse. So some calculations I did a few years ago, looking at that threshold, that 1.5 degree centigrade threshold, which corresponds to 550, more or less, gigatons of CO2 in the air. And that's the threshold beyond which, if we go, we will not only hit 1.5 degrees centigrade, but will exceed 1.5 degrees centigrade. And if you look at our current rate of 40 gigatons a year of CO2 emissions, and if we don't do anything to reduce that, or if we do just a little, then we're not going to reach 2050. We're going to be hitting that threshold by 2030, between 2030 and 2035. So the IPCC's goal of 2050 at the current rate of emissions is not reachable. It's not achievable. And so we really need to step up our efforts. Put it another way, if we do nothing, we have 10 years, maybe less, before the heat hits the fan, and before things really get significant and we reach the 1.5 degrees centigrade and then beyond. These are two plots. Looking at global warming for many years, it's really, for me at least, it's come down to two plots. I love plots. You know, I'm an engineer, I'm a scientist. Plots appeal to me. And so the first plot on the upper left is CO2 correlated to temperature going back 800,000 years. And what this shows clearly is that temperature and CO2 go in lockstep. Now, you go back 800,000 years, there were no coal-fired power plants, there were no large cars emitting CO2 gases, no industry, and so on. But there are other things producing CO2, volcanoes and so on. And so it's clear, the evidence, the data is really clear that as you change CO2, goes up, temperature goes up. CO2 goes down, temperature goes down. If you couple that with the plot on the bottom right-hand side, that's showing the CO2 in our air measured in parts per million. And what you can see throughout the last 800,000 years, it never went above 300 parts per million. And all of a sudden, somewhat after the Industrial Revolution in the 1700s, all of a sudden it spiked. And not only has it spiked higher than it ever has been in the last 800,000 years, it's done so very, very, very fast. So fast, in fact, that the temperature can't keep up with it. It eventually will, but certainly faster than we can adjust. So we need to act. Is there anything we can do? Yeah, there's plenty we can do. And we're doing some of it already, but we need to do it quickly. So in looking at this presentation and some work that I've done in the past, if I had to narrow it down, if somebody asked me, what's the most important thing we can do? Well, I have it in 4 priorities, in my opinion, that we need to do. First priority is we need to decarbonize our electric utilities. In other words, now that's a very broad topic, of course, because it includes nuclear energy, it includes solar, it includes all of renewables and wind and so on and so forth. But why is that my number 1 priority? Well, if you look at things like electric vehicles, for instance, electric vehicles are by no means emission-free. First of all, you need the energy and the emissions to manufacture them, but you need to recharge their batteries. And if you recharge their batteries, the electricity's got to come from power plants. And so if the power plants are not emission-free, then electric vehicles are not going to be emission-free. So we need to decarbonize our electric utilities so that the electric vehicles are emission-free, as would be our homes if they're all electric, changing industry into electric usage and so on. So, we could screw in an LED light and replace an incandescent light, for instance, and certainly reduce our carbon footprint. But unless the utilities become carbon-free, unless they decarbonize, while that might help, it doesn't solve the problem. Second priority is carbon capture. That is where we pull CO2 out of the air. And unfortunately, we put ourselves into a position where that's now necessary and, in my view, a very high priority. The reason, well, if you go back to my plot, we're going to exceed the threshold pretty quickly. And once we exceed it, there's no turning back. CO2 will stay in the air for generations and generations, unless we actually grab it and pull it out of the air and put it underground or somewhere else. And so because we're definitely going to be exceeding it, we're definitely going to be exceeding the 1.5 degrees centigrade. If we want to get back to 1.5 degrees centigrade and below, then we need to get carbon out of the air and we need to capture it. There's a lot of work going on carbon capture. It's not here yet. It's not commercially available, and it's expensive, but we need to continue to work on it. Most people understand global warming. They understand what it is, and they understand what we need to do. But I think where most people miss it is that it's not cheap. To solve global warming can be very, very costly. And so my third priority is that we need to get control of the costs and get the cost down. Give you an example. Okay, just talking about carbon capture. If we talk about direct air capture, here are some numbers that I pulled from the literature. These numbers are soft, I admit that, and they're changing, hopefully going down. But when I last looked, it takes about $120 to $250 per ton of CO2, including storage, to pull it out of the air. So if you look at what we're doing now, globally, we emit 40 gigatons per year. And so that means that it'll cost between $5 to $10 trillion per year, every year. Just looking at direct air capture. That's a lot of money, but if I compare it to the global warming damage that's occurring, and here it gets a bit subtle. So again, these numbers are soft, I admit that, but it's something to start with, okay? It's an anchor where we could work from. Global warming is causing damage of $2 to $10 trillion per year. So that's what we have to compare it to. So we're going to be spending $5 to $10 trillion per year for carbon capture to save $2 to $10 trillion per year in damage. If I was the chief financial officer of the solar system, and one of my managers from Division Earth came to me and presented this as a financial opportunity, I would reject it. Based purely on finances, I'm not going to make any money, and depending on where the numbers fall, I might actually lose money. So it's not a very good financial investment. Unfortunately, many, many people, taxpayers, venture capitalists, lawmakers that have to make these kind of decisions, they're also going to look at these numbers. And they're going to say, well, if I can't make any money on it, why should I do it? Let somebody else do it. And so that's the reason why, as a very high priority, I think we need to get the cost down of all of this. I mean, that's sort of like, stating the obvious, but the numbers are such that it really is very, very important. Otherwise, people are not going to make the investments. My fourth and final priority, it's all about us. You remember us. We're the two-legged primates running around the planet that have gotten us in this mess in the first place. So the first thing that we need to do is we need to understand and believe global warming. So I separate those as two separate items. Understanding global warming is pretty straightforward. There's a lot of resources you can go to. You can understand the science of global warming, what's happening, what we have to do. But more importantly, in my view, is that we really need to have the issues become part of our meta beliefs, part of what we truly believe to be part of who we are. To give you an analogy, a very simple analogy, I know water boils at 100 degrees centigrade. Okay, it's a fact. It's not very important to me, but it's a fact. However, what really is important to me is that every morning I need that cup of tea to get going. So I know academically, I know that I need to boil my water to 100 degrees centigrade. But more importantly to me, is that tea that I take every morning. Same thing with global warming. It's one thing to know about the facts, but it also has to become part of what we believe and who we are in order for us to take real serious action. We need to pick our leaders. I mean, we need to pick leaders that will put global warming issues and their solutions before their own personal gain, before their own party's gain, really before their own country's gain. It's got to be a global issue. We need to reduce our own carbon footprint. Now, please understand, reducing our carbon footprint is not going to solve global warming. It's way, way too late for that. So why do it? Well, if you look about my previous priority about reducing the cost, we need to reduce our carbon footprint so we make it easier for the real heavy lifters like nuclear, like solar, and so on, that are going to solve global warming. And by reducing our carbon footprint, crucially, it really addresses the previous priority that we need to get the cost down, because without reducing our carbon footprint, without getting the cost down, it's going to be very, very difficult for people to agree to some of these solutions. You know, it's really important. We need to take advantage of the business opportunities. Global warming solutions are $1 trillion a year market and growing. And so do you want to solve global warming? Well, turn it into a business. Okay, bring some of that money into your own companies, into forming your own business, into your own country's interests, into the global interests. It's not just pain. Okay, we got to stop global warming. We've got to solve it. It's also about the advantages that we can take because of the financial opportunities it offers. Most importantly, it's the right thing to do. You know, I looked at every major religion, and without exception, every major religion states global warming is happening, we're responsible for it, and we need to do something about it. So it's also very, very important from an ethical, moral point of view, to mention nothing of making the life livable for our children, our grandchildren, and many generations that come after us after that. So my book has 4 parts to it. The first part is why people deny global warming and what we can do about it. The second part is what global warming is from a scientific point of view, and although it's really written for the general reader. Part 3 is why we believe global warming is real and significant, what science is, and finally, what we can do about it. I would be very, very pleased to give presentations on this anywhere. I have PowerPoint, I can travel, I can go anywhere globally, instantly, virtually. And so if you have a group that would like to learn more about any aspect of anything that I have knowledge of, just contact me at rdesaro@er-co.com. That's rdesaro@er-co.com. You could also reach me through Bentham, the publisher of my book. If you want to learn more, here's a code that you can take a snapshot about, and you could find me at Robert DeSaro Author. That's where I have my Stack articles, Facebook, and Instagram. So let me thank you. I really appreciate the time that I've been given to make this presentation. I think it's crucially important. And I'd like to tip my hat to everyone in the audience listening to this and similar presentations, because it's crucially important. And as a global community, as a global civilization, we really need to act. We really need to act now as one. Thank you.
And with that, I'd like to say thank you so much for listening to our presentation today. We are BenthamScience publishers, proud supporters of the Malaysian Technology Symposium 2023, and of course, the United Nations Sustainable Development Goals. Do have a look at our website, eurekaselect.com, to learn more about our publishing company. And thank you so much for your time.